And then we'll go ahead and take a look at the pre and post condition thing. So the first thing I want to do is to show you where, which in the module I'm talking about, so that when you guys want to read the notes, you know exactly what we are talking about. We are done with constant assignments, simple self-referencing assignments, conditional statements, and now we are down to loops, which turns out to be quite a hairy topic. So the first thing we want to do, just like with conditional statements, is to draw a picture. Okay? So in this case, we'll just use the code that is already in the notes as an example, as a starting point. And instead of just reading the notes, you can see that this slide is also kind of long. But instead of reading the notes, I'm going to use a picture to explain it. So if you have a piece of paper and a pencil, I think that will be helpful. If not, you can try to type up something, to represent, what I'm talking about here. If I want to draw a picture to represent this logic, how would I draw the picture? Well, the first part is, we have an assignment statement, which is pretty easy. X gets initialized to 0. Then we have a loop. This is a pre-checking loop. Do we still remember how to draw a pre-checking loop as a picture? Okay, there's a way to come back in, and then after that point, there's a way to get out of the loop. That. And if you do not get out of the loop, you can specify an operation. In this case, it is x gets x plus 1. After this operation in the loop, you have to go back to the beginning. And the way you decide whether you want to get out of the loop or stay in the loop is to ask a question. In this case, x is less than 3 is the question I'm asking. If it is true, you continue and perform another operation. And then you go back. If it is false, you get out of the loop. So are we okay with this picture? It is consistent with what we have explained so far about pre-checking loops. So what I want to do is to say, I want to start with a precondition here and come up with a post-condition here. So I know the exact effect of a loop. Okay? Which is the focus of this class and as well as a part of the previous class. Okay? So if you read the notes here, we'll say, let's just say that pre1 is true. Okay? Pre1 is true simply means that we don't know anything about x at that point. Do we have to know anything about x for this algorithm to work? No, because x gets overwritten the first thing in the algorithm. So whatever we knew about x has to be forgotten anyway, so we might as well just say that we don't know anything about x to begin with. Okay? Any questions at this point? No? Okay. So without any derivations and stuff like that, I know that post 1 is simply going to be x equals to 0. Okay? Because we have to apply the forget operation to true. True does not mention x at all, so there's nothing to forget. But then the post condition is going to be true and x equals to 0. True and anything is just that anything back, so we know the post condition is just x equals to 0. So I'm bypassing that derivation for now, because that's not the focus of this particular picture. Okay, now we have some other places to label. How would I label this part here in terms of pre and post condition? I would just call that pre3. How about that? Would that be good? After all, this is the condition that has to be true before line 3 executes. So it makes sense to call that pre3, the precondition of line 3. Similarly, this is going to be post 3. This is the post condition of line 3. Not a problem. This here is our post 4, the post condition of line 4. Great. Well, doesn't look too bad until we try to specify these conditions. Okay? So once I have labeled all the pre and post conditions, I will switch back to my full screen editor here. So whatever I say and type will also be recorded. Okay. So this has to do with the pre and post conditions of a loop. Okay. All right. So this picture is the only part that you have to kind of draw a picture and remember that. Everything else, will be recorded here. What do you think is pre-3? According to this picture here, what do we know for sure at pre-3? How many ways do we have to get to pre-3? In other words, how many ways do we have to get to this spot here? We got 2 ways, okay? The first way is coming straight in without going first one iteration. The second way to come back here is to say that we complete one iteration and then we come back to this point. Is that making any sense so far? But regardless of which way we come from, x less than 3 must be true. Because every time I get back to this place, I had a chance to get away, if x is not less than 3. The fact that I'm just about to execute line 3 means that x is less than 3 must be true. Okay? So the way to specify that is to say x is less than 3 must be true, and on top of that, there are 2 ways to get here. The 2 ways to get here means that I have to get past, this statement here, which means, post 1 has to be true. Or the other way is to complete one iteration, which will lead me back to this point, and I will be back to pre-3 again. So in that case, post 3 is true. Is that okay? Does everybody understand why pre-3 is x is less than 3? That part is simply because if x is not less than 3, we would have branched out and exited the loop already. The or part is the more tricky one, because we could have come in the first time without going through at least one iteration, or we could come back to this point after a iteration. So it is post 1 or post 3. If you want to simplify that, you can simplify a little bit, not a whole lot in this case, because x is less than 3 is still there. Post 1 is x equals to 3. X equals to 0. But we don't know what is post 3 at this point. We know what is post 1, but not post 3. Post 3 is still kind of like a mysterious thing. We don't know exactly what it is. Are we okay so far with pre-3, the precondition of line 3? Yep, okay. So now we look at post 3, which is going to be kind of a mess. Okay, post 3, if you think about it, well, really should not be a big problem. This is line 3. Line 3 is x gets x plus 1, right? We know how to do with assignment statements already. So we'll just say, explain it here. Okay, step 1. So I'll break it down into the steps just like before. Step 1, the right-hand side of line 3 refers to the left-hand side. That's pretty easy. The expression x plus 1 does mention x. That's all it's saying. Step 2, the function of the right-hand side, f of x equals x plus 1, has an inverse. The inverse is f prime of x, which is x minus 1. Well, we kind of know that stuff already. We talked about it a few times just today. So that means we can apply step 3. In step 3, we use the substitution method to derive the post condition. Okay? Does everybody understand why we can now use the substitution operation? There's an inverse function. Okay? The inverse function is the key to being able to use the substitution rule. So we just blindly apply the substitution rule here. The substitution is going to be based on the precondition of the same line. We want to take all the occurrences of the variable on the left-hand side, which is x, and replace every single one of them with the inverse function applied to x. Just like that. This part is completely mechanical. There should be nothing mysterious about this part. And we can figure out some of the details, not everything, but we can figure out some details here. In other words, we can take a look at pre-3 and say, okay, pre3 is this mess here. So we just copy and paste it here because we are just expanding what is the precondition of line 3. We take occurrences of x and replace every single one with x minus 1. Okay, so we just also copy and paste here. But now we have a problem, don't we? Because in order to derive post 3, what do I need to know? Post 3 itself. Okay? Post 3 is on this side. Post 3 is also inside the substitution operation. I cannot perform the substitution operation when post 3 itself is still unknown. Okay? So I'll just write down here and say that, well, we have a little bit of a problem. We have a little bit of a problem because post 3 is on both sides. Okay, well, if that is the case, we just move on to post 4. What is post 4? Okay, look at post 4 here in the picture. How many ways do we have get to post 4? Let's not be specific about this case. In general, how many ways do we have to get to post 4? Once again, 2 ways. Okay, the first way is we come in through here and then we just take the bypass right away. The second way is we have to go through at least one iteration and then we go exit the loop. So there are 2 ways to exit the loop, but in both cases, guess what? X is less than 3 must be false. Okay, so that's why post 4 is going to say it is not the case that x is less than 3, and the 2 cases. We have post 1, which means in this case, we are going straight to exit the loop because the condition was false to begin with, or post 3 because we have to go through at least one iteration. Is that part okay? Okay. And we can do some expansions here because, not x is less than 3 is just to say x is greater than or equal to 3. Post 1 we already know, so we can just copy and paste the post 1. Post 1 is x equals 0, or post 3. Post 3 we still do not know what it is. Are we okay so far? So at this point, I cannot get to post 3 and I cannot get to post 4 because both of those mention post 3. It seems to me that post 3 is a fairly important thing in this entire derivation, in this exercise. Do you guys agree? It seems pretty important. Okay, so I'll just write down here. It is also in the notes, so there are many places to locate this. Okay, post 3 is important because it stays true in the condition in the loop, and also when we exit the loop. Okay, because if you think about it, the stay in loop condition, which is pre3, mentions post 3. If you look at the post loop condition, which means the condition after the loop exits, it also contains post 3. So post 3 is important because it is a condition that does not change. Okay? This is a condition that does not change. And hence the name, it is the loop invariant. Post 3, the condition that has to be true at this point, is called the loop invariant because it is the one condition that has to stay true when you are going through the loops or when you have exited from the loop. With the only exception of, you don't have to get into the loop even once, then the loop invariant will not be true. But most loops, you will go through at least once, because otherwise, if you can guarantee your program will never enter a loop even once, what is the purpose of the loop? Okay? So are we okay?